Here's number 7 from section 3.3. Find the derivative of y with respect to the appropriate variable. In 7, we have an independent variable of x. So we're after dy dx in this question. Let's analyze the function first. We have x times the inverse sine of x. So that's going to imply we need a product rule derivative there, plus the square root of 1 minus x squared. That's going to be a chain rule. Let's begin. Product rule is going to work something like this. We have the first function x times the derivative of the second function, and that's inverse sine of x. So that's a new function rule we're going to use, and it's 1 over the square root of 1 minus x squared. There's no need to do any sort of chain rule there because inside that inverse sine is just an x. Plus the second part of the product rule. We're going to do the second function, inverse sine of x, times the derivative of the first, which is just in this case 1. Now we move on to the root 1 minus x squared. That derivative looks like this, a 1/2 to the front times a 1 minus x squared now to the power of negative 1/2, and then complete the chain rule times the derivative of 1 minus x squared, which is negative 2x. Let's start simplifying. In the first term, I see x over the square root of 1 minus x squared. In the second term, just that inverse sine of x. And then in the third term, there's some simplification. 1/2 times negative 2 is 1, and that leaves us with a negative x, which I'm going to write in the numerator, and then the denominator, we'll take our 1 minus x squared to the negative half, drop it down, so that we have root 1 minus x squared in the denominator. So what does that mean for our simplification? I'm noticing that the first term and the third term are opposites of one another. When you add opposites, you get 0. So that means our last remaining term is just the inverse sine of x, and that's our answer to 3.3. Pretty neat problem that took a function with a fairly complicated looking rule, x inverse sine of x plus root 1 minus x squared, and turned it into a fairly simple derivative, inverse sine of x. That's everything here.